Hello everyone, this is Dr. Vaughn, and today I will be demonstrating for you some tips on doing the application exercises for your weekly worked out homework. So I've chosen a couple of problems from section 7.7. I will be doing some even numbered problems. Remember that you are asked to complete the odd numbered problems. One thing that's special about section 7.7 is that all of the problems are actually labeled as part of the application exercises. In the other sections, you'll see regular practice exercises, and the application exercises usually come later in the section. So for this example, I thought I would just talk about a couple of these. The first one I wanted to look at is application exercise number 20. So I already have the solutions all pre-populated in this particular Word document, so today I will not be demonstrating for you the use of the equation editor that I used to do some of these equations. You can look at the other video for tips on how to use that. One of the things that I like to do with all of my application exercises, I encourage you to do also, is to be very clear about defining what your variable is going to be. In this case, let x be the number of bass in the lake. And then I always try to keep things in context of the problem as long as I can until I get to the point where I have an equation to solve. So this was a problem about tagging some bass in a lake and then releasing them back into the lake and then doing a sample later on to determine how many fish are in the lake. This is an actual process that's used, at least here in Arizona, by members of the Arizona Game and Fish Department. So it's a real-world application. This is really the way that the game managers monitor the fish populations. So they tag a certain number of bass, they release it into the lake. In this particular case, they tagged 50 bass, and the proportion, therefore, of the tagged bass to the total bass in the lake can be written as a proportion or a fraction, 50 over x. And then once they kind of get all mixed up, now we go get our sample, which had 108 total fish in it, and 27 of those were tagged, so we can have this proportion of 27 over 108 as being the ratio of tagged fish to total fish in our sample. So of course then the proportions of the tagged fish to those total in the lake should be roughly equivalent to the ratio of the tagged fish in our sample. It's not going to exactly equal. This is just an estimating procedure, but this is the one that we have to work with. So the rest of this is really just writing out how you solve this problem. Many people will think of cross multiplication. I like to reinforce the concept of multiplying both sides by the least common denominator, which is 108 times x, and that clears away all the fractions and leaves you with just a linear equation to solve. You multiply the 108 times 50. In this case, I've reversed the x and the number, divide both sides by 27, and at the end of all of this, I get a solution of x equals 200. Now, what many students will do is put a box around this and go on to the next problem. But one of the things that I will ask you to do in all of your application problems every week for your worked out homework is to go one step further and always write your final answer as a sentence using units and giving the context of the problem. In this case, what is x equals 200? That's the correct answer, and for the odd numbered problems, you'll have this answer in the back of the book. But take that extra step to write this out, as this is the number of fish that I'm estimating to be in the lake. So I've taken that answer and I've written a complete sentence that contextualizes the response. So please go through this kind of a process when you're solving these applications. Show all of your work along the way, give some context, and get your answer, and then always return to the context at the end of the problem. Now, I thought that I would also show you an example of the distance, rate, and time kind of problems which permeate this section, and many of you will probably choose to do questions like this. And again, the one I've chosen is an even numbered one, so that you have plenty of odd left for your work this week on your worked out homework. So this particular one is about a canoe going upstream and downstream. There's many different variants of these kinds of distance, rate, and time problems. What I didn't put over here is that time is always distance divided by rate, or distance is always rate times time. So I take the information that's kind of given to me in the problem. I define my variable again. The unknown is the rate of the canoe in still water. And then you add the rate to when you're going downstream, it goes a little faster because of the current. So you add the current to this unknown rate for the rate of the travel downstream, and you subtract it because you're going against the current when you go upstream. So this is given to me in the problem, the distance, These are the rates that I just wrote as variable expressions, and then I used division to get the time. Because what's given to me in the problem is that the time spent on each of these two different trips, 2 miles upstream and 6 miles downstream, are equivalent to each other. So I have this rational expression and this rational expression, and those are equal to each other's. And this is how then I can get an equation to solve. So the rest of this is just going through, and I'll just kind of pause. You can look at this and pause the video and look at the work that I've written out. The rest of it's solving this rational expression. Again, multiplying both sides by the least common denominator, which is the product of the two denominators in this case. The x minus 2's cancel, so I just have the 2 and the x plus 2. And over here the x plus 2's cancel, so I have the 6 and the x minus 2. And again, this is the same thing as just using what some people would call cross multiplication. I like this better than cross multiplication because when you start adding something on, this technique still works. Whereas if you have something added on, you have to get a common denominator before you can do the cross multiplication step. Alright, so then you just distribute the 2, distribute the 6, clean everything up, add and subtract and everything from both sides. And at the end of all of this, you get x equals 4. So once again, I return now to that complete sentence, reminding the reader what the context of the problem is. The canoe can travel an average of 4 miles per hour in still water. Alright, so I hope this has been helpful to you about how to write out your application problems for your weekly worked out homework. It also has some context for those of you that are currently working in section 7.7, and I hope this has been useful to you. Have a great day.